Hello everyone, welcome to Maths with Smart Tips. Today in this video we are solving the questions of Nbhm PhD 2021. Question number 1. This question is from ordinary differential equation. The question says that a smooth function y of a single variable satisfies the differential equation y dash minus 2y dash y double dash minus 2y dash plus y equal to 4, and the initial conditions are y0 equal to 5 and y dash 0 equal to 2. Then find y1. So this is a simple questions of ordinary differential equation. First we write the auxiliary equation. So auxiliary equations are m square minus 2m plus 1, this is equal to 0, and the roots of the auxiliary equations are m minus 1 whole square, this is equal to 0. That means m equal to 1, and so we get the double root of the auxiliary differential equation. And we know that this for this type of differential equation, the general solution is y equal to complementary function plus particular integral. So now complementary function equal to, we have here, since m has double root, therefore complementary function is equal to suppose a x plus b into exponential x, where a and b are arbitrary constant, and we have now find the particular integral. So if we write this equation, y dash y double dash minus 2y dash plus y, and in terms of d it should written as d square minus 2d plus 1 into y, where d stands for d dx. So now we find the particular integral. So the particular integral equal to 1 by d square minus 2d plus 1 of the function 4. Now since this is a simple constant function, so this is equal to, we can write 1 plus d square minus 2d and the inverse of these functions operating on 4. And if we expand, we don't need to expand this, so this is equal to simply 4. Now the given general solution is yx equal to a x plus b exponential x plus 4. Now applying the conditions given, the conditions are y0 equal to 5 and y dash 0 equal to 2. So y0 equal to 5 and y dash 0 is equal to 2. If we apply y0 equal to 5 here, then we get 5 equal to x means a into 0 plus b exponential 0 plus 4. So this gives simply b plus 4. So this implies b equal to clearly 1. Therefore yx, this is equal to, you can write ax plus 1 exponential x plus 4. Now we apply this condition, y dash 0 equal to 2. So y dash, this is equal to simply ax plus 1, we first differentiate exponential x plus we differentiate now this function, so this gives a exponential x plus 0. We don't need to write anything. So this is simply the y dash value. So this is equal to, we can write x plus 1 into exponential x plus exponential x. Now if we apply y dash 0 equal to 2, then this gives simply y dash 0, this is equal to 2. This gives 0, so this gives 0 exponential x plus exponential x. This implies, now this gives 2 equal to y dash 0 means simply a plus 1 we get. This implies a equal to also 1. So we get a equal to 1, b equal to 1, therefore y at x is equal to x plus 1 exponential x plus 4 this. So this now we have to find the value at x equal to 1, therefore y at 1, this is equal to 1 plus 1 exponential x plus exponential 1 plus 4. So this gives 2e plus 4, y at 1. So this is the correct answer of the given differential equation problems. Thank you friends. Thank you for watching.